Definitely. This topic should be taught both in elementary and middle school. If you weren't taught this, or you want to learn it on your own, please pay close attention, because today we're going to talk about applications. Let's start with operations involving fractions. I know it's very obvious, right? But it's worth mentioning if you don't know how to solve operations with fractions. Then there's no point in watching this video, which is already about applications, so that everything I'm going to explain next will be clear to you. You already need to know how to add, subtract, multiply, and divide fractions. Also, you should already know how to convert from a mixed number to an improper fraction, and from an improper fraction to a mixed number. And also, by now, you should know how to calculate the fraction of a fraction. If you don't have a good grasp of those topics, it's important that you review them first. So, to make it much easier, I left the links to those topics down below in the description of this video. So please watch those videos first, and once you understand them well, then you can continue with this, which is already about applications. In this video, I'm going to solve 4 exercises, but here's the approach I recommend. Look, I'll show you the exercise and you pause the video and try to solve it. Once you have the answer, then continue with me and we'll see if we get the same result. Then you go to the next exercise and do the same thing. Pause the video and try to solve it. First, you do it by yourselves, and then you continue so we can see if we get the same result. And do the same with all 4 exercises, so that first you challenge yourselves, and then you see how it was supposed to be solved. You might be able to solve them on your own without my help, so come on. Let's start with exercise number 1. Juan had 54 popsicles to sell, but he only sold 5/9 of the total. The question is, how many did he have left? Or in other words, how many popsicles did he not sell? All right. Let's solve it step by step. Look, there's something important I need to tell you here. I'm going to start with simple exercises first, and then I'll make them a bit more complicated little by little, so that the last exercise will be much more difficult. So, all right, now let's solve it. Would you agree with me that to find the total number of popsicles left over, I would simply have to write the total number of popsicles I had at the beginning, which was 54. And from this, we're going to subtract the total number of popsicles that were sold. So, let's see how many were sold. It says here that only 5/9 of the total were sold. Pay attention. 5/9 of the total. I'm going to write it this way. I'm going to say that from this, we have to subtract 5/9. Of what? Of the total. But the total is 54. Pay attention, we're going to subtract 5/9 of 54. So now, this is the operation I need to solve. But notice that the word of appears here. In previous videos, we already talked about this. And if you haven't seen it, go check it out. I put it down below. We already said that when we have the word of, we're going to replace it with a multiplication sign, right? That is, the multiplication symbol. So it's going to look like this. I'm going to write 54, and then we're going to subtract this operation from it. What did we say? So it's going to be like 5/9, and here we're going to put a multiplication sign. And now we write 54. But to make it easier, what do you think? If we write it as 54 holes in the end, 54 holes is still the same as 54. And now, I ask you, well, start thinking. Which operation do we have to start with? Subtraction or multiplication? Very good, with multiplication. This is according to the order of operations, right? We always have to respect it. So let's see. We'll solve this multiplication first. So I'll have 54, I'm going to write it down for now. Notice that I'm not going to do the subtraction yet. Minus, and we do the multiplication. Here, we have a multiplication of fractions, right? So you have to multiply numerator by numerator and denominator by denominator. We start by doing 5 times 54. I'll do it right here. Okay, 5 times 4 is 20. So I write down the 0 and carry the 2. 5 times 5 is 25, plus the 2 I carried makes 27. So I end up with 270. And that will be divided by 9 times 1. 9 times 1 is equal to 9. We continue from here. So we get 54, which for now I'll keep as is, and we're going to subtract whatever I get from this division. In case the result of this isn't a whole number, we can just leave it as a simplified fraction. But I want you to see that here it will be a whole number, right? Since 27 divided by 9 gives me 3, this means that 270 divided by 9 will give me 30, right? So here we have 54 minus 30. For now, we already know how many popsicles he sold, right? How many did he sell? Well, he sold 30, right? Because we had agreed that he sold 5/9 of the total, and I want you to see that these 5/9 of the total, which was 54. I'm bringing it over here, I'm bringing it over here, and I'm bringing it over here. So, what I have here actually gave me 30. So that means he sold 30 popsicles. So now, how many did he have left? Well, he had 54 minus 30 left. And how much is 54 minus 30? Very good. It's 24, right? So the result is that he had 24 popsicles left. All right, we're done. We already have the solution for exercise number 1. Let's make it harder with exercise number 2. A pitcher contains 3.5 liters of water. 5/4 of a liter are used to prepare a drink, and then 3/2 of a liter are spilled. Question: how many liters of water are left in the pitcher? Would you agree with me that in this case, we only need to do a subtraction, right? So come on, let's set it up. But let's see, which numbers do we have to subtract? Well, look, we would have to put this one first, which is 3 wholes and 1/2. And to this, which is the total amount the pitcher has, we're going to subtract what was used to prepare the drink, which is 5/4, and then we're also going to subtract this 3/2, which is what was spilled, right? So I would have 3 1/2 minus 5/4, and then minus 3/2. We can write it separately, or we could put it all together in a single operation. In this case, I'm going to put it all together in a single operation, because I think it's important for you to practice as well. When we have 3 fractions, so come on, let's do it. Look, let's write down the 3 wholes with 1/2. I'm going to put it right here, 3 1/2. And we're going to subtract these 5/4 from this. So let's write minus 5/4. And right away, we're also going to subtract these 3/2. So we write it down, done. This is the operation I would have to solve, but you'll agree with me that I can't do the subtraction directly. The reason is because here we have a mixed number, and over here we have fractions. So first, I have to convert this mixed number to a fraction. And how did we convert it? Well, it's very simple. We multiply the denominator by the whole part and add the numerator. That has to go in the numerator. So we do. 2 times 3 is 6 and 6. Plus 1 is 7. We're going to put this in the numerator, and in the denominator, we're going to leave the denominator that this fraction already has, which is a 2. Does that mean that 3 1/2 is equivalent to 7/2? And now we're going to subtract this 5/4, and we're also going to subtract this 3/2. All right. At this point, we already have the operation set up that we need to solve. And well, the solution is pretty simple now, right? Really? So the hard part here is supposed to be setting this up? So if you already know how to solve operations with fractions, what comes next is pretty simple, right? All right. I'm going to do it using the least common multiple method, meaning I'm going to find the least common multiple of the denominators. What's the least common multiple between 2, 4, and 2? Well, it's 4, right? Because if you do 2 times 2, you get 4. 4 times 1, you get 4. And 2 times 2, you get 4. So, that least common multiple, in other words, 4, we're going to use as the common denominator. And now, we're going to divide 4 by each of the denominators, and we're going to multiply by the numerators. So, 4 divided by 2 gives me 2 stars, and 2 times 7 equals 14. We write down the 14, then comes a minus, and we do the same. 4 divided by 4 is 1 times 5 gives me 5. Let me write it correctly. 5 and then minus. 4 divided by 2 is 2. And 2 times 3 is 6. Don't forget, we always do this one divided by this one and then multiplied by the one above, okay? All right, let's do this operation. I'm almost out of space over there, so let's continue here. So what would I have left? 14 minus 5 is 9. Right. And 9 minus 6 is 3. So, I have a 3 left in the numerator, and in the denominator, we have a 4 there. That's it. So we have that the amount of water in the pitcher is 3/4. 3/4 of a liter. That's it. So is this the solution? We finished exercise number 3. Pay close attention, because this one is a little more complex. It says, a rope measures 4.5 meters and is cut into pieces, each piece being 3/4 of a meter. 2/3 of them are used to make bracelets. The question is, how many meters of rope are used for the bracelets? Really, like I was telling you a little while ago, it's important that you try it. You can pause the video and do it by yourselves. Then, when you have the answer, continue with me so we can see if we get the same result. Okay. Or even so you can see, even if you got the same answer, if the process we followed was different, either way, we should get the same result. If we do it right? All right then, let's solve it. The first thing I'm going to do, so I don't have this number as a mixed number, is convert it to an improper fraction. So, let's see. Let me write it over here. Here we have 4 1/2, right? We're going to convert it. We said to multiply and then add. 4 times 2 is 8. Plus 1 gives me 9. 9. What is it, halves? There we have it. So, the rope measures a total of 9/2 of a meter. Remember this information. Then it says that this rope, which measures 9/2 of a meter, is cut into pieces of 3/4 of a meter each. Pay attention. We have a rope that measures that, and then we're going to cut it into pieces that measure this, 3/4 of a meter each. If I wanted to know the total number of ropes, would you agree with me? What I have to do is take the length of the big rope, which is this, and divide it by the length of each of the pieces, which is 3/4, right? It's like if I told you with whole numbers, we have a rope that's 5 meters long, and we want to make pieces of 1 meter each. So, what would you do? Well, I would divide the 5 meters. Sorry, by 1 and 5 divided by 1 would give me 5. With that, I could get the number of pieces I'm going to have, right? In that case, it would be 5. Well, here I do something very similar. I would simply have to divide this number, which is the length of the whole rope, by the length that each piece needs to be able to know how many ropes we're going to get. Yes, perfect. So let's do this division here. So I'm going to write it over here separately. I'll put total ropes. I was going to write total ropes, but it's better if I write total parts, right? Because really, there's only one rope, right? That's the one we're measuring. So, let's see. Let's find the total number of parts. Like I said, what we have to do is divide this by the length of each of those little parts. So we write 9 divided by 2. I'll write it without units for now, okay? And we're going to divide this by the length of each part, which is 3/4 of a meter. So let's write that down. This is the operation we have to do. It's a division of fractions. And how did we do fraction divisions? Well, simply by cross-multiplying and then also cross-multiplying again, right? So I get 9 times 4 equals 36. This goes in the numerator over 2 times 3, which equals 6. This goes in the denominator. Done. Now we do the division, if it can be done, and if not, well, we just simplify. In this case, it can be done, right? 36 divided by 6 gives me 6 done. That means the total number of parts is 6, that is, of the whole rope. I have a total of 6 pieces, where each of those pieces or parts measures 3/4 of a meter each. I have 6 just like that one, right? Let's continue reading. Then it says, the ones we got, that is, from these 6 parts that I already have, 2/3 of them are used to make the bracelets. So what I'm going to do now is look at those pieces that were 3/4 of a meter each. Let's see how much is used to make the bracelets. And how do I figure that out? Well, it's very simple. If it's telling you that only 2/3 of that part is used, the operation I have to do would be 2/3 of what? Well, of the length of the piece, which is 3/4 of a meter, so I'm going to do this operation. 2/3 of 3/4. But we already agreed that 2/3 of 3/4 can be solved with a multiplication, right? So, I would have 2/3 times 3/4, and now, well, let's do this multiplication. In this case, it's pretty simple, because I see that 3 goes into 3 once, so to speak. We can cancel the 3 with the 3, and I'm left with only a 2 in the numerator and a 4 in the denominator. We simplify, and I get half and half, which gives me, finally, 1/2, right? Half a meter, half a meter. That's the length of the piece of string that's used to make the bracelets, right? Let me recap so you don't get confused. We had agreed that from the pieces we got, these little pieces that were 3/4 of a meter each, 2/3 of each one is used to make the bracelets. So I already did that operation. I did 2/3 of 3/4 and 2/3 of 3/4. It was solved with a multiplication, and in the end, I got half a meter. So that means what you need to make a bracelet is half a meter of cord. But now the question is, how many meters of cord are used for the bracelets? Does it refer to all the bracelets? Well, if for each of the bracelets you're using half a meter, and I have a total of 6 parts, right? So, the final operation I have to do would be 1/2 times 6, right? Because from each of those parts, I'm going to take half a meter, but I have a total of 6 parts. So come on, let's finally do that operation. So we're going to put 1/2 of a meter, which I'll just leave like that, times 6. But that's 6, let me write it right away. As 6 wholes. We do the multiplication of fractions. 1 times 6 equals 6, and we divide this by 2 times 1, which is 2. Finally, 6 divided by 2 equals 3. All right. That means I'm going to need 3 meters in total to make the bracelets. With this then, we've solved the exercise. All right, let's move on to the more complicated exercise number 4. This last exercise might seem easier than the previous one, but I really think it is more complicated, because a lot of people get confused here. Look, I'll read it and first tell you where people get confused, and then I'll do it correctly. He has a 3-meter ribbon, right? Then it says from there, he cut 2/5 of a meter. And then, pay attention, from there, he cut 2/5 of a meter. So from the 3 meters, he's taking away 2/5 of a meter. Then it says, and then 2/5 of what was left. A problem here. Well, the question is, how many meters of ribbon does he have now? There's a problem here, which is where most people get confused. What they usually do is this. They normally write 3 minus 2/5 and then again minus 2/5. But that would be wrong, right? Here's why. Notice that here the units are meters. That is, it's 3 meters of ribbon. We're going to subtract 2/5 of a meter from that. You can do that direct subtraction, but you can't subtract again. These 2/5 are here. Why not? Because these aren't meters. They're 2/5 of what was left over. So, isn't it saying that he's subtracting another 2/5 of a meter afterward? For that reason, it's not enough to just write 3 meters minus 2/5 minus 2/5. That would be wrong. So if you already did it that way, that's not correct. First, we would have to figure out what was left after he cut these 2/5 of a meter, right? And then, after that, we continue with this other operation. Let me do it so it becomes clear to you. Let's first write down what Grajeda had at the beginning, which was 3 meters. And from that, we're going to subtract the 2/5 of a meter. They're meters, and these are also meters. So if I can do the subtraction directly, I won't write the units, but we already know the result will be in meters. Okay, for this case, let's do this subtraction to make it easier for me. I'm going to write this 3 as 3 wholes, and we'll leave the minus 2/5 just as it is. Let's solve it. We'll do this subtraction using the butterfly method. For this, we have to multiply diagonally. 3 times 5 equals 15. We write it down, then it would be minus 1 times 2, which equals 2. And then we're going to divide this by 1 times 5, which equals 5. You can also solve it using another method, but I'm doing it with the butterfly method. All right, let's continue. Let's do the subtraction. And the numbers in the numerator, 15 minus 2 is equal to 3. And in the denominator, we have a 5. Done. Sorry, 15 minus 2 is 13. I was saying 3. Sorry, 13. I just wanted to see if you were paying attention. Okay, well, here we have it already. So sorry. 13/5 of a meter. Those 13/5 of a meter are what Anna had left after she cut this part, right? She has this left at the moment, but then look, it says, and then, so then she cut 2/5 of what she had left. So from this, we're going to take away 2/5 of this. No, we're just going to take away 2/5. We have to take away 2/5 of this. So the operation should look like this with what she had left. So I'm going to write this number, which is 13/5, and we're going to subtract 2/5. Of what then? Of this same thing, right? That is, of 13/5. And now, this is the operation we have to do with 13/5. What is left over? We're going to subtract 2/5 of what she had left. That is, from those 13/5. So, let's go ahead and do the operations. We had agreed that when we had the word of, we could substitute it with multiplication. So, I'm left with 13/5. And here we put a times, so it would be 2/5 of, I put a times 13/5. All right, now this is the final operation we have to solve. Remember, we're not going to start with the subtraction, right? We have to start with the multiplication of fractions, if we still have space over here, right? Yes, let's continue. Let's do the multiplication. I'm going to bring down this 13/5 for now. If you want, you can do this operation first and then do the subtraction. I'm going to carry everything along. Okay, so we don't forget the process. All right, let's continue. We put a minus sign and do this multiplication. 2 times 13 is 26. This goes in the numerator, and in the denominator, we have 5 times 5. 5 times 5 is 25. All right, finally, let's do this subtraction. I think it's easier in this case to do it using the least common multiple method, right? So, let's go. We write the least common multiple of the denominators. The least common multiple between 5 and 25, well, it's 25. So I put 25 in the denominator, then I have 25 left. 25 divided by 5 is 5, and 5 times 13 is 65, right? We put it next. Then it's minus 25 divided by 25 is 1, and 1 times 26 is 26. We do the subtraction. 5 minus 6, you can't, so it becomes 15. 15 minus 6 is 9. That one became 5 minus 2, which is 3. All right, I'm doing the subtraction. Okay, and in this case, well, it's 25. So now, how many meters of ribbon does he have now? So he has 39/25 of a meter? Would this be the solution? You could convert that to decimal, but the point is for us to work with fractions. That's why I don't recommend converting it to decimal, because, I insist, the point is to test ourselves and see if we can work everything with fractions. If we convert it to decimal, honestly, it becomes a different topic from what we wanted to practice. And well, that's it for today. I hope the video was helpful and above all, that you liked it. If you did, please subscribe to this channel. And also, you would really help me a lot by sharing this video with just one person. I'm not asking for more. Just one person who you think might find this useful. See you next time. Take care and behave yourselves. Bye.